Welcome to the Async Coding Interview series by Paul Fruitful. In this season, we'll be focusing on data structures. Grab your popcorn and stay tuned. Welcome to another episode on the Async Coding Interview Data Structure series. So, in this episode, we'll be looking at the implementation of the circular linked list. Stay tuned and grab your popcorn. So this is the definition of a circular linked list. Before I start defining it, I just want you to know that the circular linked list is like a singly linked list with a circle. So in the definition, you're going to understand it better. A circular linked list is a linked list with each of its individual nodes having one pointer to its next node. It's just like the singly linked list, but the first node has a next pointer to the last node. It looks just like a circle and there is no null value in it. So that is one characteristic that just entirely differentiates it from the singly linked list, the fact that there is no null value in it. So we'll be looking at more things and more resources that will help us understand this better, from the implementation to the visual depiction to the real world object that has similarity with the circular linked list. So stay tuned. So this is the image depiction of the circular linked list. So as you can see, there are three nodes in this linked list, and each of them has the next pointer to the next one, and the last one being 72 has a next pointer to the first one being 23, the head. So it's just like that, and as you can see, it forms a kind of like a circle. It's just like a circle, but the shape in your eyes might be like a square, but it's just a circle. It has a cycle. So next we'll be looking at like a real world representation of what it looks like an object in the real world that shares similar features and characteristics. So if you look closely, if you're following this series closely, you would have discovered that in almost every linked list, I always use a chain as an object that physically represents them. And yes, because chains are like the closest object I can think of that are similar to linked list, and the circular linked list can just be like a circular chain, the chain tied on somebody's leg. You see, it has no end. It can't end. Like if you're traversing each of the nodes individually, one by one, you're going to end up at the first one you started at. That's just what the circular linked list is. So we'll be looking at the implementation of the circular linked list next. So the implementation of the circular linked list. So if you followed closely this series closely, you discover that in every linked list implementation, I always start with the node class. Why? Because the node class is what controls the node object, and the node object is what is going to be inserted into the linked list. So the node class consists of the node class of the circular linked list consists of three attributes, just like the singly linked list: the value, the next, and the index. So it's that simple. So you can look at this pseudocode. We set the value attribute to the value argument, the next attribute to the next argument, and the index attribute to the index argument. So it will be called this class will be referred to in the circular linked list class. So it's that easy. You can implement this pseudocode in any of your preferred languages. And pseudocodes, like I always repeat the definition so you can sink in, the pseudocodes are just like codes written in an imaginary language. Like as you can see, this code doesn't follow any particular syntax. So this is the circular links class. So this class is what houses the nodes, that node class that was initialized before now. So this class is what handles it and manages each node object that is going to be put inside it. And it has two attributes, the head and the length. So the initialization, the head is initialized to null. You'll be asking, you'll be asking yourself right now. I told you in the definition of the circular linked list that there is no null in the circular linked list. So why is null assigned to the head attribute when it's initialized? Okay, you're going to see why in the next method I'm going to be explaining, the insert method. You're going to see why the null is there. So the head contains all the collections, all the nodes. The length shows the current length of the circular linked list. So this is the insert method, and it's this method that creates the magic of the linked list. So this is what inserts nodes into the circular linked list. So it takes in an argument of a value argument, which then it creates a variable named node and keeps assigns it to a node object instantiation. So it sets that node object instantiation attribute value attribute to the value argument, then its next attribute to the current head, and its index the current length of the linked list. Then it updates the current head to that node instance, to that node object instance. Then this is where there's a variation between the circular linked list and the singly linked list. There's going to be, if we are going to fetch the first node that was inserted into the linked list, which always have the index of 0, we fetch it through the get node method. I'll be explaining the get node method next. So when we fetch it by 0, we set its next to the current node that was inserted, and that is how we form the circular linked list. Then after that, we increase the length by 1. So still stay tuned while I keep on explaining most of these methods and their pseudocodes and how they work. And note you, this is not based on any programming language syntax. This is just a pseudocode, an imaginary code, or based on an imaginary language, something like that. So you can implement this in your preferred language. So this is the get node method with the circular linked list, and it's very similar to the singly linked list. The singly linked list get node method, but there is always a slight variation. So the get node method takes in an index argument and uses it to search through the collection to find if any node has a matching index, and if it does find it, it returns that particular node. So it creates a copy of the head. It creates a copy of the linked list head attribute, as the variable storing or the attribute storing of the nodes, and then it uses a while loop to index, to traverse the copy while the current node is not 0. The current node index is not 0. Like in the singly linked list, you discover that the while loops running conditional was if the copy is not null, because null represents the last node. But in the circular linked list, there is no null in it. So if you're going to put null, it's going to run infinitely. So that's why I said the copy dot index, as long as the copy dot index is not 0, the loop keeps running to each node, because 0 is going to be the last node of the linked list collection. So it's that simple, and it's easy to understand. If you also go back to the last episode, that's the last two episodes, that's the singly linked list implementation, you understand this get node method more. So if you haven't, I would advise you to go and check it out too. So this is the check if exists method. So what this method does is it checks if a particular value exists in the circular linked list. Just like it uses the same mode of traversal like the get node method. So it creates a loop that keeps running while the current node index is not 0, and it keeps checking each of the nodes, each of the individual node their value, and if it finds anyone with an equal value to the value argument, it returns true. That means it returns that that particular value exists in the linked list. But if it doesn't find if it doesn't find any node matching that value, it returns false. So you can see this if conditional here. It checks if the value is equal to val return true. So that means the loop will break, or else it sets it to the next node. So it keeps on setting it to the next node, linearly traversing the linked list till it gets to the end, which is the node with the index of 0. Okay, so this is the print method of the circular link list. As its name suggests, it prints the nodes inside the circular link list, and it uses the same mode of traversal as the get node method and the check it exists method. So it just goes as it's traversing the list, it keeps printing each method's value and keep moving to the next node. So you can look at it in the pseudocode and implement it in your preferred language. Okay, so this is my Python implementation of the circular linked list. So you can see everything, the node class, the circular linked class, the insert method, the check if exists method. So what we are going to be doing here is that we are going to see it run live. And as I said, my print method will be displayed more beautifully like than what I showed in the pseudocode. The pseudocode was pretty straightforward, but yeah, I tend to beautify it more. So let's test out the print. We'll start with the print method. So we started how many nodes? 1, 2, 3, 4, 5 nodes. So we started 5 nodes into this linked list. So we are going to check. We are going to check the print statement and see how it displays. Okay, as you can see, the first node being 3 is next is 43, and 43 is also the last node. So you can see our node is working perfectly fine. So try the get node method. Let's try to get the node with the index of 1, and that should be 13. So let's see if it gets it. As you can see, it prints out 13, which was so the get node method is working. Okay, let's try the check if exists method. So let's check if 23 exists in this linked list, and it definitely exists. If it doesn't exist, it's going to return something like not found. So it's returned found because it exists. But if we put something like 123, which doesn't exist in the collection, is going to return not found. So it's pretty straightforward and pretty simple as it gets. So I'll be leaving the link to this particular Python implementation, and also like I promised in the last episode, I'll be making the JavaScript implementation soon, and also probably the PHP implementation and C++ and some other languages, so that all this can be more versatile and can reach to every stack, every programmer and their own preferred language, so that they can easily edit it and understand it better. So is this is probably it for the circular linked list. So in the next episode we'll be looking at the last linked list, which will be the doubly circular linked list, and it's going to be very interesting. Thank you for watching the video. I'll be leaving links to helpful resources to get you grounded in these concepts. I will be releasing a video every Friday, so click the subscribe button and stay tuned. Peace.